morning. So my name is Lawrence Jacober. I'm going to be joined by Dan Thuss in a little bit. And we're here to tell you today a little bit about how to deliver faster in-branch applications while offloading the enterprise network. But before we get into those details, I think it's important to note that you've heard over the last couple of days how the internet, and particularly mobile, has changed how we work, how we play, and how we shop. It's gotten to a point where we start to perhaps think a little bit more about being online versus the type of items we actually buy in a store. So in other words, the fact that we want to be connected all the time has driven us to different behaviors. We can start to see that with statistics like this one, where we see that about 79% of consumers actually say that the availability of Wi-Fi influences where they shop. On top of this, we also see that once they actually get into the stores, not only are they using their devices to communicate with their friends, but they're also interacting with your brand. But it's not only retailers that have started to experience this change in how digital innovation has overwhelmed essentially the branch. We're seeing this across the board with our customers, whether it's digital displays in branches from a banking perspective, whether it's the omni-channel apps we just talked about, whether it's enterprises with SaaS adoption, whether it's anything that's moving to the cloud, so applications running in AWS or Azure or something along those lines, but also the adoption of HD video, right? When you think about what is taking up most of the bandwidth from your branch perspective, HD video and software downloads are obviously pretty high on the list there. This has gotten to a point where the analysts have really caught on to this trend, right? You've obviously all experienced it yourself if you're running enterprise networks, but we're at a point where we believe that the average enterprise bandwidth will actually need to increase by up to 50% per year moving forward. We actually asked you last year, if you were at Edge, how much bandwidth you currently have available in your average store or your branch location. And 64% of you actually said that you had less than 4 megabits per second. Now, if you compare that 4 megabits per second with the average type of broadband connection that you can buy in most countries these days, you start to see that there's going to be a problem. Now, when we look at the easy solution to this, you might just say, well, you know what, let me just buy more bandwidth, right? That seems like the way to solve this issue. But if you're in IT, you know that you've been asked to do more with less for many years at this point. If you're not in IT, you've probably been told that, hey, there's no money to upgrade our enterprise bandwidth. On top of it, a lot of our customers have told us, you know, even if we had the budget, right, we might not be able to upgrade them because of the location of the actual branches themselves. So in other words, if they're in a rural location, if they're in a mall type of scenario, more bandwidth is just not available. But bandwidth is really only one part of the story. When you think about enterprise networks today, yes, bandwidth is a big component of it, but often enterprise networks aren't really enabled for speed. And speed is really synonymous with latency. So we all know that most of us, at least in our enterprise network design, try to backhaul our traffic through the data center to reach the open internet. We do this mainly for security and compliance reasons, but it has a pretty detrimental effect from a latency and a performance perspective. As you can see pretty clearly here on the diagram, we're really taking the long way around to get to the internet or SaaS providers. Now, if we look at this from an overall perspective of how does this compare to consumer-grade networks, you can see here on the blue bars, that's actually the bandwidth across residential Wi-Fi, across cellular networks, and across in-store Wi-Fi type of networks. And you can see, obviously, there's less bandwidth available, as I talked about earlier. But probably more importantly, look at the latency, right? The latency, even for a cellular network, which are known to be very high from a latency perspective and very variable, is significantly lower of what you are actually seeing in these two examples of an enterprise network. And as we all know, high latency and low bandwidth is definitely not good for performance. So for some of you who have been a little bit deeper on the web performance side, you've probably seen graphs like this before. So this is actually some research that came out from Google probably about 2 or 3 years ago, where they looked at what happens to page load time as bandwidth increases, and that's the blue graph at the top. And you can see there's pretty much a single-digit percentage performance improvement after 5 megabits per second. So in other words, even if you get more bandwidth, your page load time of your applications in your branch are not really going to increase. But when you start to look at it from a latency perspective, you can see that there's a pretty linear improvement in page load time as latency decreases. So in other words, as you go from 200 milliseconds to 180 milliseconds to 160 milliseconds, page load time just keeps getting faster. So trying to resolve that latency component is obviously a key area of improvement. Now the net of all of this, right, of the constrained network, of the high latency in the network, is that if you actually try to deliver both customer-facing as well as employee-facing web applications, you end up seeing some pretty significant slowdowns, right? In other words, this is actually just a mobile application that can be accessed by the public either in the store, on the store Wi-Fi network, or in a normal kind of residential type of network, and you can see it's about 3x slower, right? And you've probably seen this graph in many facets over the last few days, right, and many different talks. So we all know that slower pages really means higher abandonment and lower conversion rates. That's not really news to anybody. But it's not really only about the consumer-facing applications that we need to think about. Particularly when you start to think about application performance issues and the impact that they have on your work, we all know that if you're trying to watch training content in the branch, it doesn't load, rebuffer all the time, that doesn't really allow you to do your job. On top of it, we've had customers that have told us, as they try to actually have their employees use omni-channel applications to try to interact with customers in the stores themselves, if those applications don't function, right, if they're not fast, those employees are likely not to use them. So always keep that in mind from that perspective. Now, the low bandwidth and high latency enterprise networks that we just saw and talked about are really stifling the business to some degree. We've seen this in education, where educators or school districts try to deliver HD content to students on iPads. If the network isn't able to handle it, they're not able to deliver it. The same obviously goes for retail with omni-channel applications. On the enterprise side, the adoption of SaaS services, such as Salesforce, Office 365, things along those lines, have all led to a point where the enterprise networks is not really able to keep up. And then the banking side of things, particularly retail banking, has taken a leaf out of the retailer's book where they really try to invest in branch of the future type of scenarios. But once again, they've run into issues where they're often limited by the network. Now, this is one of the key reasons that Cisco and Akamai joined forces. So we're really at the first phase of evolving the enterprise network. Now, to tell you a little bit more about Cisco IWAN with Akamai Connect, which is really the first phase of this partnership, I'd like to introduce Dan Thuss.
Hi, everyone. As Lorenzo said, my name is Dan Thuss. I'm a solutions engineer here at Akamai. And I want to go into a little bit more detail about the Akamai Connect solution, talk about the features, and really dive into the primary use cases for the product. So the Cisco IWAN with Akamai Connect really offloads networks and accelerates applications. And we can do that by leveraging technology inside the retail branch, which allows you to reduce costs through network offload, as well as increased revenue by having employees be more engaged and productive, as well as having customer engagement and satisfaction within the retail store. So if we look at the Cisco IWAN solution, you have 4 key pillars. So you have VPN, so being able to establish point-to-point connections using DMVPN or IPsec type VPNs. You have performance-based routing, which allows the router to actually make intelligent decisions about which path to use, whether it be MPLS, whether it be that VPN, or going out to the public internet. You also have security services within the IWAN story. So you have the iOS firewall and cloud web security solutions. And then finally, you have application visibility and control, which really allows IWAN to look at applications that are flowing over the network and to determine the best path for those particular applications and how to optimize those applications. And so within this application visibility and control, you have the Cisco Wide Area Application Services, or Cisco WAS. And within WAS, you can think of that as your WAN optimizations. It's really your layer 4 type of optimizations. So you have LZ compression, you have TCP optimizations, and you have data deduplication. So all of these layer 4 optimizations will optimize the link between your WAS devices and allow you to optimize that WAN bandwidth. Within WAS, you also have specific application accelerators or application optimizers. And these application optimizers include Citrix optimizations, MAPI, as well as HTTP. And within this HTTP application optimizer, you now have Akamai Connect. So Akamai Connect, above and beyond what you get with the Cisco WAS optimizations, you now have the ability to cache content locally within that WAS device. And the Akamai Connect has 4 primary features. So you have transparent caching, which allows you to cache intranet content. It allows you to cache internet content. You have connected cache, which actually utilizes the breadth and scale of the Akamai platform. You have dynamic URL caching, where, say, for example, if you're watching a YouTube video and I'm watching the same YouTube video, YouTube will actually dynamically change those URLs so that they're very different. And from a caching perspective, this is normally 2 separate objects for the same video. But with dynamic URL caching, we're able to analyze those packets and actually tell and see that the video that you're watching is actually the same video that I'm watching, and we can cache that video and deliver it to you. And then finally, we have content pre-positioning, which allows you to actually pre-position or pre-warm the cache so that if you have a large file that you know that people are going to be accessing, say a catalog data or a large video file, you can pre-warm that cache so that when the first user goes to access that content, it's available in the cache for delivery at LAN speeds. So if we look at the transparent caching, connected and dynamic URL type of caching, we now, because we're delivering and caching content locally within the store or the branch, we now really don't care where that content is sourced. So it could be intranet applications, it could be your internal web applications that your employees are using on a day-to-day basis. It could be generic internet content. So say you have guest Wi-Fi for your users, or your employees are browsing out to the public internet. We can actually now cache that content locally within the branch. And you also have the Akamai platform content. So this is the connected cache. So if our customers have told us that they want to be able to cache this content on our platform, Akamai Connected Cache will be able to take advantage of those rules and allow for better caching rules about what is and is not cacheable, and really for how long. So that's utilizing that breadth and scale of the Akamai platform. And when we look at the modes of caching that we offer, we have 4 basic policies. So you have basic, standard, advanced, and bypass. So basic will adhere to the HTTP 1.1 specifications and will really only cache objects that are explicitly marked as cacheable. So this is something that most all cache engines can do. So basic mode only does what's, we're told exactly what to cache by the web server that we're caching. Now when you get into standard and advanced mode, we get into more of the Akamai's technology. So we have advanced algorithms and logic built into the Akamai cache engine that says even if we're not told to explicitly cache something, we can actually look at other cache control headers in standard mode, the last modified date, and we can start making assumptions about the cacheability of those objects. So we're taking Akamai's 16 years worth of caching experience and rolling it into this standard and advanced mode and allowing us to look at these cache control headers and really cache objects for the most amount of time as possible. So standard mode not only will cache objects that are explicitly marked as cacheable, but we'll also start looking at that last modified date. And then when we get into advanced caching, we're actually taking a slightly more aggressive approach to the caching algorithm, and we'll cache media files and more types of content for longer than standard or basic caching. We'll also try to gzip that content, so as it's being delivered to us, even if the origin server doesn't gzip that content, we'll try to deliver it to the browser in a compressed format. And then finally, the last mode, bypass, simply turns off the caching capabilities for that specific URL. Now, these caching rules can actually be specified on a per URL basis, and it will fail over or fall over to a set default mode. And standard mode is actually the default setting when you enable Akamai Connect. So pre-positioning the content allows you, as I said, to pre-warm that cache. And what this does is it allows you to utilize your networks when they're least used. So if you have a large file and you want to push that down to the cache at, say, 2 a.m. when nobody else is on the network, pre-positioning allows you to pre-warm that cache so that file is available within the cache. And now you can specify the pre-positioned object on a URL basis. You can even exclude certain file types that you don't want cached. So say if you're pre-positioning a website and you don't want your style sheets to be cached, you can exclude the CSS files. And finally, you can do a predefined schedule. So this can be on a weekly basis, on a daily basis, on a monthly basis, that the cache will actually pre-warm, go out and fetch that content. So if you are updating catalog information, POS information on a daily basis, you can actually now schedule that on a daily basis to go out and pre-warm that cache. Now, the last bullet point being able to warm both byte cache and object cache. I'll specify here that the differentiator between what Akamai is doing and what normal WAN optimization products are doing is the Akamai caching engine is going to cache full HTTP objects. Whereas a normal, if you know about normal WAN optimization technologies, you have data deduplication, which is more of a byte level type of cache. So WAN optimization will say they do have caching, but it's a byte level cache, which means as you're sending data packets through to the web server, those requests still need to go to the web server, and the web server still needs to respond, but data deduplication will actually have caches and signatures, and it'll send those signatures back over the WAN instead. And what object caching is doing, the full HTTP object caching, is allowing the router to deliver the full HTTP object, whether it be a JavaScript, whether it be that style sheet or an image, directly to the user, completely offloading your WAN. So we have 4 primary use cases for this technology, and I'm going to go through those 4 use cases here. And then we'll also talk about some of the challenges that our customers have presented us with and the results and the solutions that this Akamai Connect has been able to provide. So the first use case is accelerating intranet type of applications. So these are your internal applications, your internal web applications. And in the diagram, you can see you have a data center, and you have a branch, and then you have a WAN in the middle. And this WAN in the middle can be MPLS, it can be VPNs, it can be a completely private network. And so when we start to add the Cisco WAS solution, it's going to be a dual-sided approach. So you're going to have a WAS device in your data center, and you're going to have a WAS device in your branch office, and then the Akamai Connect piece is going to be living within that WAS device at the branch. So we had a retail customer that had a problem rolling out iPads to their store associates. So they wanted to have this omni-channel experience within the store, and so they had all of this catalog information on these iPads. You could browse products, you could change colors, you could look at pricing, you can order the products directly from the iPad. The problem was that all of the information for that iPad application was located in the data center. And so all of the traffic had to flow over the WAN, over their small MPLS pipes, go to the data center, come back to that iPad application, and their networks were so constrained that the associate actually had to make small talk with the customer while the application loaded. So essentially, the application became unusable, and this grand plan of having this omni-channel experience was unusable. And so you would actually find iPads sitting in drawers, not even being used because it wasn't worth it. So now when we add in the Akamai Connect solution, and now that we're able to cache that content locally within the store, so that it's delivered at LAN speeds over their Wi-Fi directly to that iPad, you can see that those pages loaded 65% faster within that catalog application. So that associate was now actually able to provide that better customer experience, and they were able to make more sales during that time. And not only did we reduce the page load time, we offloaded the bandwidth for that particular location by 400 megabytes per day. So that's 400 megabytes of less data that I had to traverse over the WAN, and 400 megabytes saved over their MPLS network. The next one, as you saw Lorenz talk about, is that trombone effect. We had a customer where you have a private WAN bandwidth, private WAN link between your data center and your branch, and you're backhauling. The branch is backhauling all data traffic through the data center, and then it egresses out through to the public and open internet. So in this scenario, we're actually passing through the MPLS, only then to go out to the public internet. And when we add the solution into this particular scenario, you have, again, the dual-sided scenario where you have a WAS device in your data center and you have a WAS device in your branch. And then again, Akamai caching engine lives in that branch deployment. So we had an education provider that, again, wanted to provide iPads to their students. They had an e-learning application where all of these students would get lesson plans and videos and material for use within the school. And this lesson plan, this e-learning material, took 12 gigabytes worth of data. So to download all of that data was 12 gigabytes. Now multiply 12 gigabytes by a teacher, many teachers, 30 students per classroom, 30 students per grade, or multiple numbers of users per grade, and then imagine that across the school system. And so the network for the school system was very constrained, and they just couldn't keep up. So they wanted to go to this new e-learning digital platform, but the network just couldn't handle it, especially because all of their data was flowing over the MPLS and then out to this third-party education provider. So what Akamai Connect was able to do is we actually found that all of those lesson plans and videos were cacheable. And so we could get 5 times more throughput to those students, which is massive, but we also saw 99% offload on the WAN. And when you look at that number, you think it's pretty unbelievable. But if you think about it, you have one teacher that's downloading that lesson plan for the day, and then they tell their students to download that same lesson plan, and because it's being delivered from cache, all of that data that that student needs is delivered straight to their iPad. And what that does is it not only offloads the links from the MPLS and to the public internet, but it also reduces latency for loading those applications. The students can actually start learning faster, the application loaded faster, and everything was just better within the school. The next use case is we have accelerating just generic internet content. So if you know about WAN optimization solutions, you know that you usually have to have a dual-sided approach. So the other use cases that I showed you, you always had a WAN optimization device in the data center, and you had a WAN optimization device in the branch. And that's because you have to have your protocols between those two devices. But now with Akamai Connect, you can actually deploy WAS within a single-sided scenario. So you no longer are constrained to only provide optimizations going back to the data center. You can now actually cache content coming in from the generic internet. And so in this particular deployment, it's asymmetric because you only have that one single-sided scenario. And so here we had an oil and gas provider, services provider, that is in really remote locations. And they want to provide internet access to their users at those remote locations. And they looked at all of the different web pages that the users were looking at, and they found that the latency was just too bad, the links were too constrained, and everything was just too congested. And so they couldn't really do anything to get those generic internet sites into the remote location. So now they put in the Akamai Connect solution in a single-sided scenario, so there's nothing even coming from the data center, and everything that they're caching is coming in from the public internet. And what we found is that if we looked at their most popular websites, so Cisco.com, Microsoft, a couple of news sites, CNN, BBC, we could actually reduce that by 40%. So the average load time for those sites was reduced by 40%. And the reason is because we're now caching all of that content. So if you have logo files, you have CSS, you have JavaScript, everything that's making up those public websites can actually be cached and can actually be delivered straight from the cache engine. And what we also found was that 90% of the data that was being served on the LAN was actually being delivered from the cache, which is massive. So if you have a slow ADSL link, if you have a really slow just public internet pipe or it's really congested, if you can now serve 90% of your data on your LAN, that's massive. So what they were able to do is not only get faster response times, but also offload those WAN links. And the last use case that I have for you is YouTube. So I mentioned that we can do dynamic URL caching, and in this case, we can optimize YouTube videos. So if we look at a digital signage use case, or maybe it's a kiosk, or a YouTube channel that a retailer is trying to roll out, we found that as the default quality of that YouTube video was coming in, it was loading at about 144p, which is very low def, and it actually took 14 seconds for that video to become high quality in HD and get up to 720p. And so if you are sitting in a high-end retail store and you're looking at a low-def video and it's not loading and it's buffering and it takes 14 seconds to actually become visible, that's pretty unacceptable. But with Akamai Connect, because we can now cache these YouTube videos, we can actually deliver that content, deliver that video from the router and from the cache engine, and it will load in 720p, so HD quality, in less than a millisecond. So it's basically instantly loading in HD quality. And what that means is there's no buffering, the video signage plays flawlessly, and everything works as the retailer intended. So in summary of those use cases, as I mentioned, it now really doesn't matter where this content is coming from. So you can have content coming in from your WAN, whether it be MPLS or VPN. You can have generic internet content coming in that you can cache. And you can even now deploy the solution in not only a dual-sided scenario, but a single-sided scenario. So it doesn't matter what your WAN is or what your WAS deployment scenario looks like. Akamai Connect will be able to accelerate those applications and offload those networks to increase employee productivity and customer engagement. So now if you know about Cisco WAS, you know that there's a Cisco Central Manager, which is basically a single pane of glass to be able to configure everything about your WAN optimization solution, so everything about Cisco WAS. And we've actually integrated the Akamai Connect piece directly into the Central Manager. And so within Central Manager, you can log into this single pane of glass, and we've enabled one-click enablement of the Akamai Connect solution. So here you can see I have a checkbox that says Enable Akamai Connect, and you click that, and now you're caching. Okay? We also have easy configurations. So you can specify on a per URL basis how you want to cache things. It's point, it's click, it's GUI interface. And we try to make it as easy as possible for you to start caching this content and being able to find those modes of caching and get your cached content being delivered to your users as quickly as possible. And not only is the configuration easy, but we also give you visualization and reporting of the cache. So now within the Central Manager, you can see statistics about your offload. You can see statistics about your throughput. And so you can really see what the cache engine is doing, not only offloading the WAN, but allowing you more throughput, and you can compare and contrast what it would be like non-optimized versus optimized. And you can also see a list of the top URLs that we are caching. So if you notice URLs that are in there that are always cached, you can take maybe specific actions against those URLs. So this is a unique product within Akamai. because this is really a Cisco product. It's sold by Cisco, and it's on the Cisco price list. Okay? So the Akamai Connect solution is directly integrated into Cisco WAS, and you buy an add-on license for Cisco WAS. And it runs on ISR G2 routers, 2911 and above. And you can also run it on the Cisco Wave appliances, which is the dedicated WAN optimization appliance. So with this solution, if you already have Cisco WAS in place today, it could be a simple software upgrade and a license upgrade to get the Akamai Connect features. So in summary, what we're showing here is a way to accelerate those applications while offloading your WAN, which allows you to increase revenue because your employees are more productive, your customers are more engaged, and you have a better in-branch experience for everyone that's being connected through this Akamai Connect device. At the same time, you're decreasing your IT costs because now you're offloading your WAN, which means you don't have to buy bigger MPLS pipes to roll out that omni-channel experience. You don't have to buy bigger internet pipes just because you want to provide guest Wi-Fi for your users. So you can decrease those costs by actually delivering and utilizing the hardware that you already have within the store and adding the Akamai Connect solution. And this really allows you to have now a complete network solution. So the Cisco IWAN with Akamai Connect will deliver fast and quality web pages, and it allows users to have the best experience possible within the store. That's all I've got. Lorenz? So I'm going to open it up to questions.
Yeah, so questions, the audience. All right. Morning. Do you have any comparisons to current WAN optimization that a company may already have, like CloudBridge or Riverbed or anything like that?
Lorenz?
Sure. Yeah, let me take that firstly. We do to some degree. One of the key differentiators for us, as Dan was talking about, was the capability for us to not only look at byte level caching, so in a single-sided type of deployment, but also to actually do the full object caching, both in an asymmetric but also a symmetric deployment. So that really sets us apart from a lot of the other vendors that are out there. Now, that being said, if you look at it from a kind of a feature-to-feature type of comparison, so you look at kind of WAN optimization that's part of this product with Cisco WAS versus some of the Riverbed appliances or some of the others out there, we actually still believe that we'll be ahead on that front for specific use cases.
Okay, thanks.
Questions? I'm going to stop here and I'll go to you.
With the majority of traffic being SSL encrypted, how do you plan on accelerating that, if at all?
Excellent question. And I didn't cover it within this presentation, but SSL is actually handled by the WAS appliances. So if you're running in that dual-sided scenario, the SSL certificates could actually be loaded into Cisco WAS, just the way that they do it for the last 5 years, to be able to decrypt that SSL traffic, and then we can cache that content once it's decrypted by WAS. Now, in that single-sided scenario, if it is SSL, we don't have any visibility into those packets, so SSL is not supported.
I'm not familiar with the configuration management for this kind of thing that you were displaying, so apologies if it's a question based on my ignorance. But you make the point about a simple point-and-click interface, and that's all well and good, but when you have 850 branches, I don't want to point-and-click 850 interfaces. So how mature is kind of a centralized, scriptable, API-supported config management setup for this kind of thing? That may be more of a question on the Cisco side than the Akamai, I guess.
Mm-hmm. So they've tried to make the GUI interface as simple as possible, so you can actually group your branches into various groups. So if you did want to push out a single config to 500 branches, you can do that within the GUI. But you also have a full CLI access behind that central manager. So if you wanted to go into the CLI and maybe write scripts to do anything within the CLI, all of the features and functionality that you see in the GUI from the Akamai Connect perspective, you could make those changes from the CLI. Yep.
We have a current WAS solution, and I was wondering what kind of improvement we could see with the Akamai Connect added onto it.
And you have what kind of solution?
We have WAS now.
Yep.
We wanted to know what kind of improvement we would see with adding the Akamai Connect.
And that's a great question. And I have, normally I show a slide that has that sort of data in it, and it's very compelling. Because when you think of WAN optimization, we have a retailer that had a catalog application that took about 30 seconds to load without any sort of WAN optimization technology in there. And then when you turn on WAS and you actually get now this layer 4 optimization, you could cut that time down in half, so it would load in about 13 seconds. And so that's all your WAN optimizations technologies. But then when you turn on Akamai Connect and you're actually now caching caching those objects and delivering it at LAN speeds directly in the branch, you're able to get that down to less than a second. So it does add a very powerful layer on top of Cisco WAS. Yep. Thanks, Randy.
Okay, last question.
I'm just curious. Not all store locations can justify the cost of an ISR. Is there a lighter deployment?
There is currently not today. So because you have to have compute power, because you have to have hard disks to actually store that cache, you need a minimum level of router to be able to support that compute. Yep.
All right, so that concludes this session. These guys, Lorenz, Daniel, thank you very much for the session. You guys, I guess, will be down at the expert bar if folks want to learn more about the cloud networking solution. And so, guys, there's a 10-minute break now before the next session. In here, we're going to have the net neutrality discussion will continue. There'll be a panel discussion on net neutrality. We'll drill into that a little bit more. So that'll be in 10 minutes. And then, if you would, during those 10 minutes, if you would complete the survey on your Edge app for the session, that would be much appreciated. It allows us to take your feedback and make this a better experience for you guys. So I don't know if you want to talk about this or...
Yep.
Yeah, I think the other last bit here is if you have other questions that you think about maybe after the session or anything along those lines, know that there is a cloud networking section in the Akamai community. So Dan and I are both participants in that. So if you have anything else, just post your questions there and we'll get them answered. All right, thank you.